Oh, hi there. We're going to jump into scatter plots and lines of best fit, they're called, or just lines of fit, apparently. The best is not always important. So that's the vocab, scatter plot, line of fit, and then very importantly is the word correlation. So that means, is there a relation between the independent and the dependent variables? Let's jump into what all this means. So a scatter plot is basically a graph that shows a relationship between two data sets. They are discrete points, usually collected from a collection of data. So you could be graphing like age versus height onto a XY, and that would make a scatter plot of a bunch of different points for all the different people you collect data from. And it generally will show a trend. It'll show you if there's a relationship between the two sets of data or if there's not. Okay, if you're a note taker, this is not super important, but if you want to jot it down, feel free to pause and jot this down. Okay, so here's a scatter plot right here. It shows you sugar in grams and calories for a different set of smoothies. So it looks like they collected data from, what is that, like 10 different smoothies. Oh yeah, it tells you right here, 10 smoothies. And they figured out how many grams of sugar and how many calories are in all 10 of those smoothies. So take a look at this graph. Answer this question. How many calories are in the smoothie that contains 56 grams of sugar? All right, so one way to do that is looking at the graph. Let me slide myself over. Whoop. Go over to 56 grams of sugar. There it is. Go up to the dot, and you'll notice, oh, there it is, 270 calories. That's the one that has 56 grams of sugar. So that point right there is the 56 sugar smoothie. Okay, question B, how many grams of sugar in the smoothie that contains 320 calories? Okay, so for that one, you start by looking at the 320 on the y-axis and go over to that dot right there, and it's that one. It's got 70 grams of sugar. Okay, and then the third question, this gets to correlation a little bit. What tends to happen to the number of calories as the number of grams of sugar increases? Okay, so here, as you look from left to right, these dots keep going up and up and up as you go further right. So it looks like the more grams of sugar, the more calories there are. This is a positive correlation we're going to learn about when we get to correlation. So there is a relationship between grams and calories. All right, so now correlation, identifying correlation. So this is where you might want to take notes. If you have a positive correlation, then as X increases, Y increases, and you see that in a general pattern with the dots. If the dots kind of go in a downward pattern, that is a negative correlation, which is as X increases, Y decreases. And then if they're kind of all over like a scatter plot, there's no pattern. There seems to be no correlation between the X and the Y variable. So those are the three different possibilities. Sometimes things will be very tightly correlated and sometimes loosely correlated. We'll get to that a little bit later. Right now, we're just looking at the general trends. This is a great page to take notes on. Feel free to go crazy with your dots as you're drawing your graphs. Okay, so let's take a look at these. So here we have a graph that has a bunch of different ages and number of vehicles owned. So this is this plot right here. So for graph A, is that a positive, a negative, or no correlation? Okay, so for graph A, you'll see there's no real pattern, which means that the number of vehicles owned does not depend on a person's age. There is no correlation for graph A. Okay, for graph B, the average daily temperature and the coats sold per day. Take a look at that graph. Is that a positive, negative, or no correlation for graph B? Okay, so graph B, that one is trending down. That has a negative correlation. All right. And the last thing is the line of fit. I'll put myself right there. Okay. So when you have a positive or negative correlation, you can model that with a line of fit. And basically, you're going to draw your best line that goes through the points. That's kind of what a line of fit is. All right, so feel free to jot this down. If you're a step taker, these are the 4 steps. First, make a scatter plot. Second, decide whether the data can be modeled by a line. Is there a positive or negative correlation? Third, draw a line that appears to fit the data closely. There should be approximately as many points above your line as below the line. And then 4, write the equation using any 2 points from the line that you drew. The points do not actually have to be actual data pairs. They just have to be on your line. And we're going to practice one example of that next. Okay. All right, so we have this table of DVD sales. This is slightly outdated, apparently. No one buys DVDs anymore. Write an equation that models the DVD sales as a function of the number of weeks since its release. This one is not directly linear, as we'll see. That's why we do the line of fit. Okay, so if you take all these points and graph it, you get that right there. Not completely linear, but clearly linear-ish. So is this a positive, negative, or no correlation? Okay, this one has a negative correlation, as it says right there. So what you're going to do is after you scatter plot draw this, you will then get a ruler if you're doing it on paper, or use the line tool if you're doing this on big ideas, and draw your best line that kind of goes through all these points. Like that is a good best fit line right there. And then you pick any 2 points from that line to make your equation, which I'll go through quickly because there's 6th period about to come in here. So you can use the points 5, 10, that's on the line, and the points 6, 8, those are on the line. Use those 2 points to write an equation. So you find the slope, and then you use your slope and any of the points, and point-slope form like we've been doing, and you get an equation which you can then use to solve problems. All right, that's it. So there's scatter plots and line of fit. If you have any questions, feel free to ask me during class, and I will see you as you're working on these problems. Arr!